4,000 meters below the surface, where no light has ever reached, something is sitting on the mud. Trillions of dark, potato-sized rocks scattered across a plain wider than the continental United States. They look ordinary. They are not. Inside each one are the metals that power batteries, electric vehicles, wind turbines, military electronics, and AI data centers. Every one of them took roughly 10 million years to form, and right now, the most powerful nations on Earth are racing to pick them up. China holds extraction rights to 92,000 square miles of international seabed. The United States signed an executive order to fast-track deep ocean mining, bypassing the international body meant to regulate it. And a tiny Pacific island nation with 11,500 people tried to force the United Nations to hand over the keys. The ocean floor is governed by an authority that has never approved a single mining operation. The regulations do not exist. So what is down there? What are they chasing? And why does almost nobody know about it? This is Deadly Atlas. We spent weeks pulling together the latest research from marine geologists, deep sea biologists, and policy analysts. The ocean floor is far more alive, far more valuable, and far more fragile than it appears from above. To see what is worth this much effort, we have to go down. But first, zoom out. 70% of the planet is ocean. It produces more than half the oxygen you breathe. It absorbs a quarter of all carbon dioxide released by human activity. From above, it looks like one thing: a flat, blue expanse. Empty. It is not. Beneath the surface is a landscape more varied than anything on land. Mountain ranges taller than the Alps, canyons deeper than the Grand Canyon, plains stretching for thousands of kilometers in permanent darkness, and a network of life that science has barely begun to catalog. Here is the number that matters. As of 2025, roughly 27% of the ocean floor had been mapped to modern standards. But mapping is not seeing. The total area of deep sea floor that humans have actually observed with cameras in over 70 years of exploration is less than 1,000th of 1%, roughly the size of Rhode Island. We know the surface of Mars better than the bottom of our own ocean. Everything else is inference, sonar data, gravity readings, educated guesses. So let us go down. The sunlit zone comes first, the top 200 meters where light still reaches. This is where most ocean life people can name actually lives. Tuna, dolphins, coral. Below that, things change fast. By 300 meters, the light is gone. Temperature drops. Pressure starts to climb. At 1,000 meters, permanent darkness. Water just above freezing. Pressure that would crush a human lung. But this is only the first layer, and already something critical is here. Cables. More than 1.5 million kilometers of fiber optic lines resting on the ocean floor, carrying over 95% of all international data traffic. Every email, every bank transfer, every military communication between continents. $10 trillion in daily financial transactions, running through infrastructure most people have never thought about, in a place most people have never seen. There have already been dozens of unexplained cable damage incidents. Russia operates deep-diving nuclear submarines and survey vessels capable of reaching 6,000 meters. Chinese-flagged ships have been linked to cable damage near Taiwan on multiple occasions. Some regions have no backup routes at all. The digital world depends on physical lines in the dark, and those lines are not as protected as you think. Keep going down. At 2,000 meters, the pressure is 200 times atmospheric. Life here is sparse. The seafloor is a vast, quiet desert of soft sediment. A fish drifts by. A sea cucumber processes mud. Energy is vanishingly low. And then, without warning, the desert erupts. In 1977, scientists exploring the Galapagos Rift found something no one predicted. There were no biologists on the expedition, because no one expected life at that depth. What they found were thriving communities packed around cracks in the sea floor where superheated water was blasting from the earth. Giant tube worms, clams the size of dinner plates, shrimp without eyes, Entire ecosystems in total darkness, fueled not by sunlight but by chemistry. Bacteria harvesting hydrogen sulfide from volcanic vents, converting it into food. Life does not require sunlight. It requires energy. And energy, it turns out, is everywhere. Scientists are still discovering new species at these vents faster than they can classify them. And the organisms here carry enzymes and genetic adaptations unlike anything on the surface. Pharmaceutical companies are already paying attention. The minerals are the obvious treasure down here. The less visible treasure is biological. The deeper you go, the more valuable it gets. Keep going down. You are below 4,000 meters now. The abyssal zone. Pressure roughly 400 times atmospheric. The seafloor here is a plain of fine clay and siliceous ooze that has been settling particle by particle for millions of years. Nothing moves fast. Nothing changes. And then the seafloor changes. Imagine the beam of a submersible's floodlight sweeping across the bottom. For hours, nothing but soft gray silt, flat, featureless. Then the light catches something, a dark shape, half buried in the mud. Then another, then dozens, then thousands, stretching in every direction as far as the cameras can see. Millions of dark, rounded rocks sitting on soft ooze, as if someone had scattered them there and walked away. Polymetallic nodules, concretions of manganese and iron oxide, 4 to 10 centimeters across. They look like ordinary stones, but each one grows so slowly that a few millimeters can take 1,000,000 years. A nodule the size of your fist may have been forming since before the genus Homo existed. Inside them, manganese, nickel, copper, cobalt, rare earth elements. Every critical metal the energy transition needs. The largest known concentration sits in the Clarion-Clipperton zone, an abyssal plain between Hawaii and Mexico spanning 4.5 million square kilometers. The nodules in this zone alone contain enough critical metals to reshape global supply chains for generations. They are not attached to anything. They just sit there, on the mud. That is what makes them so tempting. But before we talk about who wants them, look at what lives on them. On the abyssal plain, the nodules are the only hard surface in a world made of mud. Sponges anchor to them. Corals grow on them. Brittle stars and sea anemones shelter against them. The concentration of animal life on nodule fields is 2 to 3 times higher than on bare sediment nearby. Remove the nodules and the ecosystem does not shrink. It vanishes. And then there is the octopus. A ghost-like deep-sea species lays its eggs on dead sponge stalks that grow only on manganese nodules. Without the nodule, the sponge cannot anchor. Without the sponge, the octopus has nowhere to brood. And deep-sea octopuses brood for years. Researchers tracked one female of a related species who spent 53 months wrapped around her eggs in total darkness. She never ate. She never left. Her skin grew loose. Her body shrank. When the eggs hatched, she died. The longest brooding period ever recorded for any animal on Earth. Picture that mother at 4,000 meters, curled around 30 eggs on a dead sponge stalk, attached to a manganese nodule the size of a potato. Complete darkness, not moving, not eating, years of waiting. Her entire reproductive life depending on one ancient rock. Pick it up, and it is not just a mineral that disappears. It is an entire cycle of life. Now the biology becomes power. Here is what extraction looks like. Massive robotic vehicles, tens of tons, lowered from a surface ship on cables stretching 5 kilometers down. Tracked like tanks, they crawl across the sea floor, vacuuming the top layer of sediment along with every nodule in their path. The material is crushed. Metal-rich slurry is pumped up through a riser pipe. Leftover sediment and clouded water are discharged back into the ocean. 4,000 meters below the surface, dust does not exist. until humans bring it there. What happens next is an underwater dust storm. A suffocating cloud of fine particles drifting through a world that has never known dust. It smothers filter feeders. It clogs feeding structures that evolved in water clearer than any on the surface. It buries the already minimal food supply that drifts down from above. Life on the abyssal plain runs on almost nothing. Even a small disruption can be catastrophic. And the scars do not heal. In 1979, a company ran a small-scale mining test in the Clarion-Clipperton Zone. Scientists returned 44 years later, in 2023. On land, rain, and wind and roots would have erased the tracks in months. At 4,000 meters, there is no rain, no wind, no roots. The tracks left by the collector vehicle were still clearly visible. The nodules had not regrown. Many organisms had not recovered. 4 decades, and the scar looked fresh. Commercial-scale mining would disturb hundreds of square kilometers of seabed per year, per operation. Each contract would run 20 years. There is no replanting, no regrowth on any human timescale. What is taken is gone. Now the geology becomes politics. The International Seabed Authority, headquartered in Kingston, Jamaica, is the only body authorized to regulate mining in international waters. China holds more exploration contracts than any other country and controls roughly 70% of global refining capacity for critical minerals. The United States has never ratified the treaty that created the ISA and is now acting outside the system entirely. For decades, no one rushed. The technology was not ready. The seabed felt unreachable. Then, in 2021, Nauru, the third smallest country on Earth, triggered a treaty clause known as the 2-year rule. If a sponsoring state declares its contractor ready to extract, the ISA must finalize the mining code within 24 months. If it fails, the application can be provisionally approved under whatever draft rules exist. Nauru was not acting alone. Its mining entity was a subsidiary of the Metals Company, a Canadian startup. The deadline passed. The rules were not finished. The lock did not break, but it cracked, and every major power saw the opening. The United States signed an executive order to mine unilaterally. Norway, Japan, Saudi Arabia, South Korea, all moved forward. The Metals Company saw its stock surge over 800% in under a year. And at the ISA Council meeting in March 2026, the mining code remained unfinished. No exploitation approved. No framework for environmental compensation or benefit sharing. Small island nations are caught between the promise of revenue and the risk of ecological collapse. More than 30 countries support moratoriums. But every electric vehicle, every wind turbine, every AI server rack that will be built in the next 2 decades needs the metals sitting on the abyssal plain. And the nations with the capital to reach them are not waiting for consensus. The seabed is being divided before the rules are written. Now let us go to the bottom. Below 6,000 meters, the Hadal Zone, named after Hades. The Mariana Trench bottoms out at roughly 11,000 meters. Pressure exceeds 1,000 atmospheres, the most remote environment on the planet. There is life here, microbial communities in the sediment, amphipods swarming in the dark, and there is plastic. Researchers have found microplastics at every ocean depth, including the Mariana Trench itself. A plastic bag was identified at nearly 11,000 meters down. Amphipods collected from Hadal trenches had microplastic fragments in their guts. We reached the deepest places on Earth before we understood what lived there, and we brought our waste with us. Come back up now. The ocean floor is not one thing. It is a system, and every layer connects. Heat drives the vents. Chemistry feeds life. Nodules anchor habitat. Cables carry civilization. Laws are supposed to hold the line. Technology is moving faster than all of them. Changes in one layer ripple through every other. The minerals took millions of years to form. The ecosystems evolved over millennia. The regulations have been in progress for a decade. The extraction machines are ready now. Some systems persist precisely because they have never been touched. The deep ocean floor is one of them. The question is not whether we can reach it anymore. The question is whether we understand what is there before we start taking it apart. The fight for the bottom of the world has already begun, and we are dividing the largest unexplored ecosystem on Earth before we have even seen it.